Welcome back to Computer Science E75. As David mentioned last week, he is traveling and can't be here, so allow me to introduce David Heitmeyer, who is a lecturer of computer science with Computer Science E153, which is an entire class devoted to XML web development. He also teaches Computer Science E12, which is the fundamentals of web development class. He works as a software engineer at iCommons, and I really want to thank him for coming out and stepping in for this lecture. Thanks so much, David.
Okay, thank you. Thank you. It's my pleasure to be here tonight. Thanks for having me, and thank David too. Hope he's having a good trip. But it's always a privilege to step in and fill in for him when I have the chance. So I think last time I was in this course, I lectured on did a course on a lecture on CSS, and tonight it's XML. And so I understand last week you all covered the basics of XML, and okay. I'm going to ask, well, there's not even a cable in here. Okay, I'm going to see if we can, I thought I was all connected, but I guess not. Okay, so the basics of XML that you've covered, you've talked about well-formedness. And I also understand that you're going to be developing a pizza markup language for one of your assignments. So hopefully you've looked at that, and that might help generate some ideas as we talk about XML tonight. So XML is, last year celebrated its 10th birthday, and there's two ways to look at that. One is it's not the brand new thing on the street, so it's not the latest and greatest in terms of technology. On the other hand, being 10 years old, it is kind of in that mature phase where you can use it and you can use it very reliably. And as we'll see, there's kind of a whole family or galaxy of XML-ish things, and some of those are definitely more on the cutting edge. But last year was its 10th birthday. The W3C had a big celebration and whatnot, but essentially we have XML. If you looked at HTML, you've looked at XHTML. XML is very similar, very comforting, right? You have angle brackets, open tags, close tags, attributes, all that good stuff, and it's kind of a way that to describe data, and it makes it very easy to interoperate. So we can interoperate between languages. So if you have something in PHP and you need to feed data or get data from something that's running on a Java platform or Python or what have you, XML can be kind of a language-neutral way to exchange information and data. Likewise, if you're on different platforms, Windows, Linux, again, XML is kind of a neutral, or I should say, a platform-independent way of doing that. There are some formats in XML that are very data-centric. So we might get feeds from an astronomical telescope that's piped into us with XML, and we might process that, or from a weather station. And those are going to be very data-centric formats, very much like what you might see with an Excel spreadsheet or something like that. Other types of content might be more narrative in nature. There are XML formats to mark up ancient manuscripts, for instance. There are XML formats that are geared to very, very large document sets of whether it be articles or books, encyclopedias, document the all that you need to know about a missile system or an aircraft carrier, things like that. So XML is inherently machine readable too. I mean, you can open up an XML file and read it. And in general, you should be able to have some sense of what's going on with that. But at its core, it's really meant to be machine readable, or by that, readable by a program. Okay. And then are also XML formats that are designed to be display-oriented for people. So often you have data, you want to present it on the web, you want to present it on paper, you want to make it accessible on a mobile device, so you can take your XML data, transform it to another XML format that's more suitable for that. So this is the first example that I start off in my course, just to show people XML. Right, I guess this is the second slide we're looking at. And so something like this is not foreign to you all. So this is my made-up address book format. It has 2 contacts in it. So just a few things to note. We have one root element. So we have one element that really encompasses or encloses the entire document, and that's a requirement for well-formedness. There are 2 contact information, and we also see some attributes in there that are quoted and things like that. So from this, you can imagine giving that to a program, and it would be very easy to extract out the data for that. And that's really the strength of XML. Now, if we wanted to present this on a web page, we might take that data and make it into an HTML table. And then we could, give that to a browser, and the browser would render it like this. Now, if you're a clever programmer, you could take that HTML data and extract out the parts and figure out what the name was and figure out what the email was. But it's going to be a lot more work, and it's going to be fragile to do that. And so that's why I kind of want to make the distinction between we want to use XML to contain data. If we need to present it, there are many XML formats that we can use to present our data, but we want that to be a presentation format, not a storage and data format. So I'm not going to go through all of these. There's an article called XML in 10 Points from the W3C, and I recommend, it's very short, just 10 points, but I recommend that you read that. I've listed those points here, 1 through 10. The other thing that I'll note too, these lecture notes I'm going to make available, so you'll have these to look at. The links will be there, so it'll be nice and easy to review. So we talked about how XML is for structuring data. We've talked about how it's like HTML, a bit like. It's text-based, which is nice, but it's not really meant for people. XML is verbose by design. And by the verboseness, it's really, sometimes it takes a lot of typing to generate an XML format. You have the open tags, you have the close tags, and but if you're hand coding XML, you're pretty sick of angled brackets after a while, right? But very rarely do you actually hand code XML. You usually generate it programmatically, and there are libraries that generate XML quite nicely. So I think the number 5 I want to hit on, and we'll see another slide on this, kind of about how XML is a family of technologies. And I think that this is one of the most confusing things when you're coming at XML. There's just a lot of different things that are all under the XML umbrella. And it can be kind of hard to figure out what is this for. And then understanding the differences between, say, technologies versus specific software tools that you might use for those technologies. Point number 6, XML is new but not that new. We talked about its, 11th birthday this year. But the history of XML really goes back to the mid-'80s, that long ago, in the world of SGML, or the Standard Generalized Markup Language. So XML kind of grew out of that as a simplification of SGML. Point number 8 of XML is modular. We're going to see this in a bit too. But it's very easy to take different XML grammars and bring them together in a single document. And XML is really made to do that. And if you have an iPod or you use iTunes, you're the beneficiary of that technology. Number 9 is kind of out of scope for what we're going to talk about tonight. Very, very interesting, but we won't get into that. Point number 10, license-free, platform-independent, and well-supported. And I'm going to jump to the XML in 10 points because I like the last sentence, the conclusion sentence, which says XML isn't always the best solution, but it's always worth considering. Okay. So XML is great for a lot of things. It's not perfect for everything. Okay, so don't walk around with your XML hammer forcing everything into an XML solution. But do remember that you have that XML hammer in your toolkit when you run across problems. So here's my attempt to represent the XML galaxy here. So, oh, good, thanks for the few chuckles. So under the whole XML umbrella, there's markup, and we saw an example of a markup document with our address book. And kind of under that, we talked about how there's markup for data-centric formats and markup for narrative or prose. We can use XML for presentation. So we can deliver an XHTML document to a web browser. We can deliver an XHTML mobile profile to mobile devices. Okay. There is an XML format that we can easily render or serialize into a PDF document. So that's this XSL FO for formatting object. So it's very easy to produce a very high quality print of our data. I'm going to move that. I feel like I'm not seeing this whole wonderful section over here. XML is used a lot for exchange. So with web services, with AJAX, and I know you're going to be talking about a lot later on in this course. And so we have different XML-ish ways for programs to exchange information. And that can be server-side program to server-side program. It can also be web browser JavaScript program back to the server. There are several different ways of defining XML. So we can, if you've ever validated an XHTML web page, who's done that? I'd like to see every hand go up. So you've done that, and you know that there are rules about how to construct an XHTML document. And that's controlled by the document type definition for the XHTML markup. There are other ways of also defining XML grammar. So we can use XML schema, we can use RelaxNG, we can use schematron. But all these ways are ways of expressing what elements are available to you in a markup language, how those elements must or can be nested, what attributes are available. Definitions other than DTDs can be a lot more flexible too, so we can specify that the value of a certain attribute must be a date type. And so you might identify types in a programming language of integers, floats, strings, things like that. We can do the same thing in our markup definitions. And then lastly, kind of under the programming area, we have things like XSLT, and the key point there is the T for transformation, and that's how we can express a template language. So we can take one XML format to another. We have things like XPath, and I think you talked about XPath a little bit before, the XML path language. So you can really get to a very specific part of the XML document. And it turns out XPath is really a subset of XQuery. So if you've ever worked with relational databases, who's done that? Okay, great, about 30%. So, if you have relational databases, you have SQL. And if you have a native XML database, you have XQuery. And so XQuery is really designed to let you query a whole document collection that you might have in your XML database. And it's a superset of XPath. So if you've learned XPath or know a little bit of XPath, you already know some XQuery. And then we have things like the DOM, or the document object model, and you'll be using that a lot, I imagine, when you do JavaScript. And that's just a way of manipulating all the node tree of a XML document. We have SAX, which is the simple API for XML processing, and then we also have some very language-specific ways of manipulating XML. Things in the PHP world, like simple XML is one of those. And so it just kind of often brings the structure of XML into a data structure that's more native and intuitive for a specific language. So we talked about XML content, narrative content, data content. We talked about XML as being presentation-based. And so, again, web-based, PDF, we can do graphics with XML. So there's a format called scalable vector graphic that we can use. A lot of mobile devices are, actually really all mobile devices, modern mobile devices, except XHTML mobile profile. And here in the mobile world, it's kind of interesting that there's sort of a convergence on standards, particularly as it comes to content amongst providers compared to what we've seen and what the history has been in the world of desktop browsers. So that's kind of interesting from a development point of view. We can produce plain old text if we want, and then the other thing, we can also produce various Office-type formats. So whether we're using Microsoft's XML format that it uses natively now as of Office 2007, and there's also the Open Office, which is the Open Office equivalent of all those, and those are sort of two competing Office formats. But both those are available to us that we can use, and then deliver that XML format that someone could then open up in their word processor in their spreadsheet. So I wanted to show a quick demo here, and I took this from my E153 course, so this is specific to E153, not E75, so I apologize about that. But a very simple XML representation of a course description. So we have course number, course title, course term, meeting time, location, instructor description. Not complicated at all, and you can already probably point out some problems. All right, wouldn't it be nice to have the meeting time represented as a real day and a real time instead of just a string that we display? And you got me there. Shouldn't we break up first, last name of the instructor, and et cetera, et cetera? So we could make this better, but this will do for our purposes. So with that single XML document, I've applied a variety of different XSLT transformations. So an XSLT transformation is an XML document that really defines then how that source XML should be really transformed to another XML content. And so we can take that and transform it to a web page. In HTML, we can use XHTML as well. We can transform to a PDF. And I will say, so these links right now are happening actually live on my laptop. So the transformation is happening at the time of the request. And we'll see ways of doing that in PHP later on in the course. So here's a scalable vector graphic of that. We can output just plain old text if we want. We can output content for mobile devices, and these screenshots are shown here. Okay. So the nice thing with starting with our data, we can have output to however many different formats we want. So if our data changes, so next year when if it's taught on a different day or time, we can simply change that. And since we're performing all of our transformations on the fly, we don't really have to do anything except update our data source. We could get more clever too and allow it to accept different source documents, so we could have it easily produce that type of content for any course, as long as we had the data for it. So wanted to show another example with weather. And we're going to come back to an example where we kind of critique a weather XML format later on and try to improve upon it. But here's an example from within a portal page. On the left-hand side, there's a little weather box. And we see kind of that weather box enlarged on the right-hand side. And if we scroll down to the bottom of this slide, we see the XML data that weather feed is based on. And this particular feed comes from weather.com. And I've left it in a text area because it's kind of long and whatnot. But you can see that it's marked up. And so we have data about the current conditions and data about the forecast. So then we can really take that and then transform it into another set of markup that can fit inside of this portal box, and we can really format that how we want. So you can imagine we might give the user choices as to do they want to see kind of a condensed version of it, do they want to see the full version of it, and that would be very easy to apply those differences. There's also feeds from the National Weather Service. So if you want to play with XML, if you want to play with a real, since a real XML that's being produced, you can get a bunch from the National Weather Service. And so here's an example of how one might render it in terms of HTML. And here's an example of an RSS feed for the, I think this is Logan's. And then there's also an example of the XML feed. Now, this is the XML feed, and it looks like a web page. Okay, so but I want you to, if we do a view source on that page, we actually see the source XML. If you look at the very second line, there's a reference to an XSLT style sheet. So in this example, your browser would be taking the XML, it sees the reference to the style sheet, and if you have a modern browser, it's going to do that transformation on its own. So do be aware that if you're ever viewing XML within your web browser, it might be doing something with it. Okay, it might be transforming it so it looks like a web page. The other thing it might be doing is, let me jump back. It might be kind of making it collapsible. So here, we see the little, we can collapse the elements and things like that. So that's something our web browser is doing for us, and it makes it nice and easy to look at the XML, but do recognize that it's being messed with. That's kind of an important thing to recognize. Okay. So this is a fun example. I just wanted to show it. I'm not going to go in detail how it was constructed, but I looked at the after last year's presidential election and looked at all the different towns in Massachusetts and colored the towns red or blue depending upon the majority vote, and then colored the towns some shade between red and blue depending upon the percentage of votes that went to one candidate or the other. So this is kind of interesting because it kind of brought together two different XML pieces of data. One was the Massachusetts town boundary map, which was available from the Mass GIS website. And it wasn't available natively in XML, but it's in a very well-known GIS format. There's a lot of libraries out there. I happen to use a Perl one that converted that easily to an XML format. And so we had really a scalable vector graphic format that showed the state, that showed all the boundaries of the towns. And that SVG format can be displayed in an SVG-capable browser, which, again, modern browsers will support that. You can also convert that to a ping image if you want as well. So that's kind of one XML format. The other XML format came from the boston.com page, which had the vote data in an HTML table. So that was easy enough to extract out into something like this, where for each town we have an element, and then we count the votes of what they were. So then taking these two formats with the map, so that it has the town names and the boundaries, we know how they vote, so we can kind of bring those together and really color then, fill in the towns in the SVG based upon the data in this. And then, so that produced these images. So it's kind of a neat example, I think, of using various XML sources to kind of bring together data to do something with it. Other places where we might see XML, if we with mapping. So Google Maps, Google Earth. There's a XML format called KML, which defines place marks and paths and markers that we can use. So we can take that KML file and give it to Google Earth. Google Earth will then know how to display it. And so this particular KML file that I'm showing, I think, has 3 place marks on it. The 1 Story Street, 53 Church Street, and the John Harvard statue. And we can also take this same KML file and give it to Google Maps on the web, and it'll also display. Okay. So that's kind of interesting. And then also there's a whole API for Google, which you can use the API functionality and add your own data to that, so you can display a Google map on your web page with your custom data inside. I think last time David also talked about RSS, and the really simple syndication, or there's a variety of other acronym translations that it goes by. And that's it's a syndication format, so it's an XML file that a site would publish. And the idea is that people will subscribe to that with a RSS reader. And so that reader might be a standalone program, it might be part of their email client, it might be part of their web browser. But this RSS reader that the consumers really subscribe to, every now and then, depending upon what the feed tells it to, will pull in a fresh copy of that RSS feed. So if you have something new on your site, you can update your RSS feed, and then whoever subscribed to that, within 15 minutes or an hour, they'll get a fresh copy of that. And so that's very, very handy. Whether you're a news site, this item is taken from the BBC, but I've also seen it used for very infrequently updated things like Upton Tea. When they get new teas in, they'll put that up on their RSS feed, and so that way you always have the latest of what's happening. The core of an RSS feed are these item elements, and there's stuff around it, but these item elements are really the key to it. And they have items, or they have titles, they have links, they have descriptions. They have other stuff too, but those are the core things that they have. So the title, the short display, longer description, and then the link that goes back to the site. So there are other formats too. With Atom is another syndication format that slightly different. Some would argue better. We won't get into that, but it does something similar with item link, title link, description. So wanted to show that to also talk a little bit about the modularity of XML. So most everyone, at least if they don't have an iPod, knows what they are and knows what podcasts are. So podcasts are really just an adaptation of RSS because it's really performing the same function. You subscribe to a podcast, so your iTunes player or whatever your podcast client is goes out, grabs the latest version of the podcast, and if there's any media associated with that, it will download it so that it's ready to sync up to your MP3 player. So Apple, when they started doing podcasts for iTunes, decided not to reinvent the wheel, which was great. So they used RSS because by then it was a widely used type of syndication feed. There was a lot of software that knew how to produce it. Websites were used to producing it. They knew what it was, and they were doing it a lot. So, but iTunes needed a few extra things. So one extra thing that's not iTunes specific is this enclosure element. And this enclosure element is really the media file that's attached to that item. So this would be the MP3 player. Okay, so this is a snippet from an RSS/podcast feed from the WBUR show called On Point. And So you see the enclosure here points to an MP3 file that's accessible via the web. So then we also see these elements that are, the element name is iTunes : summary, iTunes : keywords, iTunes : duration, iTunes : explicit. So this is the modularity. This is combining the RSS grammar that has item, title, link, description, enclosure, with the iTunes grammar, which specifies keyword, summary, duration, explicit, etc. So the nice thing about this is that a regular RSS reader reads this just fine because it simply ignores the elements that it doesn't understand. If iTunes gets a hold of this, it knows how to read the RSS feed, but it will also do things and be able to process that information that's specific for iTunes. Okay? So it's kind of an example then where it took an existing format, and because of the modularity of RSS, or the modularity of XML, was able to kind of bring those two formats together. Use the strength of what was already there, but augment it with particular grammar that it needed without breaking anything. Yes?
Does that mean then that if you're using XSLT, that you can't display the iTunes keywords?
So that's a good question. So the question is, if you're using XSLT, does that mean that you can't display the iTunes keywords? If your XSLT is aware of those iTunes specific elements, you can certainly process those. Just like if your program's aware of, item, title, link, description, as well as those elements that are in the iTunes grammar, you can certainly process those. But you just have to be, you just have to have your program, or you have to have your XSLT aware of those. Another example with modularity is with, again, RSS feeds and the geotagging of being able to produce latitude and longitude. So this example uses Yahoo Maps, and so we give Yahoo Maps an RSS feed, so an RSS document, with, for each item we have a geolat and geolong. And again, these are part of a well-defined namespace. We'll talk more about namespaces later. So when an RSS reader gets a hold of this, it would see, oh, this is David's favorite lunch spots, and there's only 3 of them, a creature of habit. When Yahoo Maps gets a hold of this, it's able to understand the RSS feed, and it's able to understand the geographic information, and it can display those. So again, the modularity of XML is really, really helpful. So to kind of take a look into how the modularity works, I wanted to show an example where we've taken an XHTML page and combined it with a math markup language page. Now I realize, if you're not a mathematician or a physicist or a chemist or in the sciences, math markup language may not be the most exciting thing to you. But it's a neat example of how things can combine. So if we were to display this math markup language, we see a bit of the code. But if we display that in a compliant browser, we can do neat things with, creating equations that would be really hard to do otherwise. We'd have to create GIFs. We'd have to use tech. That's even worse than math markup language. I apologize to any tech enthusiasts out there. But so we have some text that gets rendered and some fairly sophisticated mathematical ways. So to take a look at what's going on here, we see at the very top we have our HTML, and then we have an XML-ins. That XML-ins is a XML namespace. Okay. And so and then we have an XML-ins : MML. This is doing 2 things. So the namespaces really are declaring the different grammars that we're dealing with in XML. So the first namespace declaration is to XHTML. It doesn't have a prefix. Okay, so it's just plain XML-ins. So here we're establishing what the default namespace is for that entire document. So if we ever have an element in that document that does not have a prefix to the element name, then that element belongs to the XHTML namespace. So when a browser gets a hold of this, it can very well understand this is HTML or XHTML, and I display it such. And then the namespace prefix MML that we declare attaches to the math markup namespace. And so then whenever we have an element with an MML prefix, that belongs to the math markup language. And so this is a way when we're processing, you can know which element names belong to which prefix. No, that's exactly the wrong thing to say, David. You can tell which element belongs to which namespace and which grammar. And so you can process things differently. And so that way you can combine all sorts of different grammars together and not worry about clashes in terms of names. Okay, there's probably lots of different XML grammars that define title. Okay, but you can bring XML grammars together and not worry about that. Okay. Yes?
Besides MML, are there some other common XML namespaces?
I took out the slide that has a whole document that lists a whole bunch of them. So there are. Anytime you have different grammars being brought together, you have the potential for these different namespaces. So in RDF, there's various people data. There's namespaces to define data types in XML. So there's a variety of things. But I do want to make a distinction between the prefix. So this MML, the MML itself is totally irrelevant. It's only relevant in that it's defined in this document to be tied to that URL. We could have said XML_math or XML:_m, and as long as we use that consistently within our document, we'd be fine. So the prefix is a convention that we need to be internally consistent, but the meaning, kind of the reality, is created by that URI up top. So you can combine scalable vector graphics with XHTML as well. And often is what you'll find is if you're creating your own markup language and it's centered around a specific data type, and you're finding yourself you're needing some types of text markup in a description field. So instead of inventing your own strong EM, I, B, things like that, or inventing your own table structure, you can simply use those modules that are already defined in XHTML. Okay? And so that you can just have people author XHTML tables and have those included as your content, and then it'll be very easy to process. Okay, so more namespaces. Okay. So one of the points in the XML in 10 points was that XML is new, but not that new. So 11 years old, history going back a couple decades into SGML. So the standard generalized markup language, that's been around since the mid-'80s or so. That's what first gave us HTML. Okay. So one thing to make a distinction, so the top box, right, where you have SGML and XML, these are ways of defining markup languages. Now, what examples that we have below are specific markup languages that we have. Things like DocBook, things like HTML, things like XHTML, MathML, SVG, and so on. So SGML and XML really just give us the framework to define specific markup languages. So SGML was quite successful in some, not in a widespread way, but it was very pervasive in certain areas and certain industries. One issue with SGML is that it provided a lot of flexibility. And if you've dealt with HTML, you've seen some of that flexibility. So in HTML, we don't have to quote attributes if they don't have spaces. We can, but we don't have to. Some in tags are optional in HTML. So we don't have to have a closing P, for instance. We don't have to have a closing TD. And then there are some other things as well. But in that sense, it's more lenient in terms of the well-formedness rules compared with XML. The consequence of that was that it takes a lot to write a good SGML parser. And it turned out that the different vendor solutions for SGML parsers weren't consistent enough that you could write SGML that was cross-platform in the sense of you give your SGML to one vendor processor, you're going to get something different than if you give it to something else, to another vendor's processor. So that doesn't make for a good situation as far as SGML being a good markup language to kind of create data that can be consumed and produced everywhere. In the mid-'80s, you didn't have, networks weren't as free-flowing with information, and so that wasn't as much of a drawback. But once the internet comes along, you begin to notice these things a little bit more. So XML is really a simplified subset of SGML. So we said, forget all this, let's make it stricter. And require in tags, require quotes, require some things that make writing a parser easier, and so that it can be more predictable. So that's kind of the relationship between XML and SGML. And then we have languages that are defined in terms of the XML language. Yes?
What do you give up when you go to XML besides the sloppiness? Is there extra functionality? Is there something good you're giving up when you go to XML?
So the question is, well, what do you give up when you go to XML? And compared to SGML, I don't have a good answer for that. So I don't think you're giving up much, and I think you're gaining a lot. Now, it turns out, but the only thing that I can think of, and this is kind of grasping at straws, you've seen DTDs before, and so XML DTDs are even less flexible than SGML DTDs. So you can define in SGML DTD some sorts of exclusions, so that you can say an A can't be within an A. That technically can't be done in an XML DTD.
Can't you do that in XML schema?
But, well, right, so the comment was, well, can't you do that in XML schema? Exactly. So there are, in that case, that shortcoming, there are a whole host of other XML ways of defining documents, and they kind of go beyond what DTDs are able to do. And so really the world of SGML, I think it's fair to say, really hasn't evolved since XML came along. So it's not so there are a lot of things now that you can do in XML that you can't do in the SGML world. And in fact, all the two, what I would say, main widespread document types in SGML, DocBook and HTML, all have XML equivalents, and really in the modern use of them, use the XML versions of those languages. Okay, so I've already made this point about XML. It's not a markup language in and of itself, but it just gives us a way to create markup languages, so specific ones. Some markup languages will be very general in use, things like XHTML. Some languages might be very specific. It might be very specific to, a pizza restaurant, or real estate properties, or DNA sequences. So we find that within particular industries and areas, can be some very specific XML grammars defined. Now, the beauty of XML, again, is so not only is it modular, it's not monolithic in the sense of there's no one place to go to look at all the grammars that have been defined. But if you want to start, there's a couple places that I would begin: Oasis Open and XML.org. So if you want to use XML in your particular realm of expertise, and you're not aware of XML standards in that area, go to these two places to check first. And maybe you'll find a pizza markup language there. I don't know, but I doubt it. So you talked last time, too, about XML documents being well-formed. And there's some pretty basic, handful of basic rules for that, right? You have one root element, attributes need to be quoted. You need start tag, you need an end tag, even if it's an empty element. What else? You have to have proper nesting of things, so you can't have start A, start B, close A, close B, but you can nest your elements that way. And then you have the character entities, less than, greater than, ampersand, quote, and apostrophe that you have available to use. So, and if you follow all those rules, you have something that's well-formed. And that's good, because if you don't have something that's well-formed, it's not XML. So you can't even get off the ground with an XML parser if it's not well-formed. So the other thing, and I think David's slide about with the DOM kind of showed a representation of an XML document in terms of a tree structure, or in terms of nodes. So in the world of DOM and in the world of XPath even, and XSLT, you really talk about nodes of an XML document. And so I think when you're looking at XML, if you can begin to kind of visualize a tree in your mind, I think it's really going to help as you approach it from a programmatic sense, regardless of whether that's in PHP or XSLT or JavaScript and DOM. So, so the root then of this XML document is address book, and then underneath address book we have two contacts. Right? Within contact we have name, address, city, state, zip, right? And then within name we have the text node available, and we might have attribute nodes that hang off of our element nodes. But we kind of have this tree of things where we have parents and children and siblings and things like that. So in this structure, contact is a child of address book. Our two contact elements are really siblings of one another. Right? Name is a child of contact, and it's also an ancestor. It's a descendant of address book. Conversely, contact is a parent of name. Address book is an ancestor of name. Okay. Yes?
So I see that you have phone and attribute.
Yes.
In type equals office. So can you have multiple phones if they have different attributes, or is that just more of a clarification?
Okay, so that's a good question. So the question is, with phone, we have a type of an attribute, and the question is, can we have multiple phones if they have different types? So I'll answer that in two ways. One way is, in terms of XML, we can have multiple phones. It doesn't matter. We can just list all those out. They don't even have to have different type attributes. Okay, and we'd still have a well-formed XML document. Now, from the specific grammar, we might define it and constrain it in such a way that it requires phones to have, but we haven't really done that here. So we don't really have this type of grammar defined. So in a pure XML sense of being well-formed, there's no restriction on having multiple phone elements or multiple elements of the same name. But we might choose to constrain that when we're creating our grammar. Yes, question?
I'll try to ask this question as clearly as possible. The basic question is, there's one root element.
Yep.
Inside the root element, you can have multiple root elements.
Yep. No, they wouldn't be root elements.
I know they're not really root elements, but you could, in the secondary level, let's say you want information for a contact-employee, which would be different than maybe contact-home resident. And the
Yep.
type of information is so different.
Yep.
In some ways, yes, you could have it well-formed, so you have, contact employees, how you do it this one, and then contact homes. In some ways, you could make it well-formed, but does that defeat the purpose of XML? Am I making my question clear enough, or is it?
I think you are. So the question, I'll try to re-express it. The question is really in terms of design of the XML information, and the comment was, what if you have a contact for a home contact whose information looks very different than an employee contact information? Kind of what would you do with that? I'm going to put that off. We're going to talk about XML design in the second part of the lecture, and so we'll hit on that. We'll hit on that a bit then. So we do have this, we do have this tree structure, and if you can kind of begin to visualize this in your mind, your experience with programming XML is going to be so much better than if you think of them strictly as elements and strings of text with these funny angle brackets that drive you nuts. If you have an XML editor, and I suggest that you get one, and now let me qualify that. If you have your favorite text editor, then all I suggest is to find a way for it to, enable the XML mode so that it will give you syntax highlighting. So I don't want to start any editor wars here. So your favorite XML or your favorite text editor probably deals with XML just fine, and you just might have to find that particular mode for that, and that'll give you some syntax highlighting, and it might do some other things as well. So this is a screenshot of an example of Stylus Studio, I believe, which takes that XML and kind of displays it in this tree format for us. Yes?
So Unix-based basic editors like a Pico and Nano can also do XML highlighting?
Pico, NetVI, Vim, yes, they will all do XML highlighting for you. So, you've gotten this far in your programming life with your favorite XML editor. I'm sure it'll handle XML for you as well. Emacs, there's a lot of great modes in XML for Emacs if anyone's an Emacs fan. But they'll prevent you from making silly mistakes like not quoting an attribute or leaving a tag open. So that'll be helpful. And some of them will help you kind of also visualize it in a tree mode and not just a text mode. So XSLT and XPath. We'll just jump ahead. We got about 5 minutes left. Is that right, or so? Okay. So XSLT is the extensible, right? X in all XML is extensible. Extensible style sheet language for transformation. So the key here is T, the transformation, transforming from one XML format to another. And then the XML path language, or XPath. And these really work together. So XPath really is not a language that's meant to be off on its own. It's really meant to work alongside something else, and that something else is usually either XSLT or XPointer. So really within this, we're going to be kind of looking at both XSLT, although we'll do that later. We'll take a look at XPath first. There's sort of two versions of XSLT and XPath, and again, because they hand in hand, the versions march together at the same time as well. XSLT and XPath 1 is fairly old, or you could also say mature, and it works quite well. Version 2.0 is a lot more flexible, so all the issues in terms of not bugs, but in terms of things that people wanted to do within XPath 1 or XSLT 1. And a lot of these had to do with things like dealing with dates, dealing with strings, finding unique things. A lot of those are made a heck of a lot easier with XSLT 2 and XPath 2. And those kind of reached the recommendation state a couple of years ago. And those are less widely supported, although there are some really good tools out there that do support those versions. I think this is a screenshot from lecture 3 that you saw. So where we have an XPath expression, and we have our XPath steps that are divided by slashes. We have XPath attribute, or not axes, there we go. So we have the child axis. Lectures would denote then an element name. So we have, so if we were to kind of visualize or actually draw out the XML that this is really built against, right? We have lectures, lecture, and then that lecture would have an attribute of number. So then within here we might have information about that lecture, and we might have lecture number 1, etc. Okay. So then the square brackets then are predicates in XPath. And if you can think of the predicates as a filter. Okay. So the XPath expression tells us what we're selecting. So we're really selecting lecture nodes based upon the lecture element that's a child of lectures. Okay. So that's what we're selecting. So we're going to get back a node based upon that element lecture. But the predicate that we have here says, well, we only want that lecture whose number attribute, that's the @ sign, the value of the number attribute is equal to 0. Okay. So this particular expression would then pull out the node that's based upon this part of our document. So really, that element, all of its attributes, in a sense, would come with it, or I should say all the nodes based upon the attributes, as well as any nodes that are within here. And there might be more elements within here. There might be PC data within there. We don't know, but we'd get all that out from that XPath expression. So within a XML document, we have several different node types. So we have the root node, and here, strike that. We should say, instead of not root node, we should say document node. So and that's typically shown as simply /. So the document node is really the container of the entire document. Within that, we have the root node, okay, which would just be an element node. In a sense, it's a special element node because it's the root node of the document. We also have attribute nodes, and then we have text nodes. Those are going to be the things that you encounter most commonly. Okay, element nodes, attribute nodes, text nodes. If you have comments in your XML, those will be accessible in your parser, in your DOM as comment nodes. We can also have processing instruction nodes and namespace nodes. Those last three are not as common as the first, but element, attribute, text nodes will probably get you where you need to go in the vast majority of your XML world. And when we come back from break, we will begin to dissect this image. So we'll break for a few minutes and then come back. So this image comes from Norman Walsh. Norman Walsh is one of the guys in the XML world that if something comes from Norman Walsh, it's good stuff. So this is an image from one of his tutorials. But I think this is a great illustration of all the different axes that are available to us within XPath. So I think child is very natural for us to use, but there's several others as well. Some of them more commonly used than others. But the circle and bold, so this overall is really our tree of all the nodes that we have in our XML document. Kind of here in the middle, the dark circle is our self. And so you can imagine that you're sitting there in that, you are that node, be that node. And then there are several different axes that are available to you. So the child axis, right, is going to look at all the nodes that are direct children of you. And keep in mind, too, that in XPath, the default axis is child. So in XPath, we have axis name, : and then we have an element expression. So if you don't see axis name : then the default is it's child. Okay. So also, if we're self, we have the descendant axis, and the descendant axis covers our children as well as the children's children and their children, etc. So basically, any element that we contain would be our descendant. There's also an axis which is descendant or self, and that covers all of our descendants plus us. Okay, so those are kind of the axes that kind of look down in a sense. Axes that look up, so we have a parent. Okay, so there's a parent axis. There's an ancestor axis, so that would cover, not just our parent, but our parents' parent and our parents' parents' parents, et cetera, et cetera. And then there's also ancestor or self, which would include all of our ancestors plus us. So then there are other axes. One is the preceding sibling. And this is where it's important to note that document order does matter in XML. Okay? So when our node tree is built, it's really built in document order. So preceding siblings are those siblings. So in a sense, we have those nodes that we have the same parent, but that have preceded us in the document. And then we also have following siblings. And so if we wanted all of our brothers and sisters, we could get our preceding siblings, our self, and following siblings. All those together would be, or we could just get all the children of our parent. And we'd have the same thing. So then two other axes that are a bit not used that often, but they're preceding and following. And they can be kind of confusing because it's not always clear what is truly preceding, what is following, and then there's a whole host of things that don't fall into either one. But the key here is preceding elements are those elements that have closed before you. Okay, so if an element has closed before you, it's included in this preceding axis. And then if elements begin after you, not within you, but after, it would be in the following axis. Okay. So,
I think that it's got to be in order. Like if you have an item and it has description and name and price, that you can't do price, name, description.
So that's a good question. So the question was about my comment about how order is important. And so if you have an item, and could you have name, price, description, or could you have description, name, price? So that would depend. So your grammar could require they be in a certain order. Your grammar could specify it doesn't care what order. But I think the difference is, and maybe the way to think about it, if we have item, and then as a child we have price, description, title, and then as document 1, and then as document 2, if we have item, we have description, title, price. So these two documents would be semantically different. They might have the same information, and according to your program may handle it the same, and the output might be the same. But if you look at it strictly from an XML-ish point of view, they would be different. Whereas if we have, if we have it in the same order with the same information, and we just have extra carriage returns and tabs, those would be really semantically the same. So the other thing that I'll mention too is the attribute order is unimportant. So say we have an item here, say we have a size and location attribute. And we list location first and then size. Okay, those would still be the same. So element order important, attribute order unimportant. Yes?
Does your definition of preceding and following depend on the serialized representation of your XML? It seems like it does somehow.
Well, so the question is, does your preceding and following depend upon the serialization of your XML? And I'm going to turn that around, and I'm going to say our node tree depends upon our XML document that's serialized. So you're right. So we have a serialization. We have our XML that's serialized. We read that in. we have some sort of tree structure. But I mean, we could certainly create a tree structure without the bytes, okay? But so our axes really don't. Our axes really depend upon the node structure and the tree structure. What I said about the closed tags and the open tags, that's, I think, just an easy way to think about preceding and following. But you're right in that my hint about what it is does depend upon it being serialized out. But since that's how often we look at XML, it's kind of a natural thing to do.
So is there a more formal definition then?
There is a more formal definition, and you can look in the XPath spec for that. I can't recite it to you offhand.
In response to her question, when you rearrange the order, if the price is closed before you get to the next one, even though it's lower than description, the preceding following relationship really wouldn't change. Or in a sense.
Well, so the comment is about if we're changing the order of these, and I'm really kind of drawing these as nodes here, so I'm assuming price is closed before description and title. So I think my only comment was that if we change the order of these, we have a semantically different XML document. Okay. Now, when we process, well, certainly it would affect preceding following depending upon your context. So if we have description, price, and title, and if we're at price, our preceding nodes would include description, following would include title, but it wouldn't do it here. Yep. But let me also say, though, that I mean, typically in cases like this, like in an RSS feed or item link description, usually those languages are defined in such a way that order is unimportant in terms of the markup language. I'm speaking strictly in terms of how something looks to an XML parser. Okay. So I think that picture, if you remember that picture, you'll be able to navigate XPath axes quite well. And if you want them listed out, they're right here. So we mentioned about how child is the default axis. And other axes have shortcut methods to them. So we can use parent : : and in name we can also use the shortcut ... So if you're used to navigating in a directory structure, right, and you go to the parent directory, same thing here. ... / goes really up to your parent. Self can simply be dot. The attribute nodes, or the shorthand method is, the shorthand notation is the @ sign. And then the other shorthand notation that we have is descendant or self, which is //. So normally / is just a path separator. But // is really shorthand for descendant or self. Okay. And that can be handy, and it can also be expensive. Because if you're at the root node of your document and you say descendant or self, you're causing your XML parser to parse through every single node in the tree, looking for that expression. Sometimes you have to do it, but sometimes there are better ways and more efficient ways. So to talk a little bit about XPath predicates. So the predicates are these things in square brackets that really filter what we're selecting. Another thing to note is that the result of an XPath expression, or what's really returned, is going to be a sequence of nodes. So you can think of a sequence as a list, but formally it would be a sequence. It might be a sequence of one thing, but it's always a sequence. Okay. So, and I'm not really being totally fair here because I'm not showing you the XML that we're selecting against, but David said you were a bright class, so I'm going to leave it to you to kind of fill in the XML source structure blanks here. So if we take a look at number 1 under courses, so we have begin with slash, so that's really we're beginning with our document root. Courses would be the root element. So we're selecting all the course elements under courses. And then our predicates, we have 2 predicates here. One is our academic year being 2009 and our offered attribute being yes. So that's going to return, right, we're going to get back a sequence of nodes based upon all the course elements in our document whose academic year is 2009 and the offered string is equal to yes. Who wants to tell me why the 2009 is not quoted and the yes is quoted? String and number, exactly. So, and this is an XPath 1 expression. In XPath 2 is what we'd want to do. We'd want to say at offered EQ, quote Y, single quote. Okay, because in XPath 2 we can test numbers differently than strings. We can't do that in XPath 1. If we did not have the single quotes there for the Y, the XPath expression would interpret that Y as an XPath expression. So it would look for a Y, in a sense, a Y element that's a child of course, and think that we're trying to test against that, which we aren't. So that's why you always have to remember strings, quote. You'll be fine. Number 2 does exactly what number 1 does, just slightly differently. Okay, so second example here with Congress. Right, so we have root element Congress, we have person elements. Within those person elements, we have roles. Okay, and these, roles really define: are they a representative? Are they a senator? What party do they belong to? When does their term end? Et cetera, et cetera. So the first expression, we'd get back a sequence of person elements whose attribute type of the child role is equal to SEN for senator. So we would really be looking at the type attribute of the role, and that role is a child of person. So we don't have an explicit attribute axis there, but the default axis is child. Likewise, the number 2 would be selecting out all the persons who have roles and who really belong to represent the state of California. Okay, so RSS, some things that we might get out of by using XPath. So RSS channel item, and then predicate position equals 1. So let's leave out the predicate. If we just say RSS channel item, we're going to get back a sequence of all the item nodes in the RSS. So the predicate then on that sequence is position equals 1. Now, in I think most programming languages that you're probably familiar with, right, indexes of lists start at 0, but not in XSLT or XPath. So the position 1 is actually the first item. And I know that's confusing, but that's the way it is. Likewise, position equals last, we would be pulling out the last item. Okay, and we pull up all the even items. And now our predicates don't always have to be on the end of things, and that's why I threw number 4 in. So we're selecting all the even items. Okay, so that's that sequence. And then the further path expression is child : title. So we'd get back a sequence of all the title elements, the nodes based on the title elements, of all the evenly positioned items. Okay, yes?
I have a question about number 5.
Yes.
Hypothetically, you had multiple news items that have the same title, and you wanted to get a unique list of all the titles. I did this in PHP with the array unique function.
Yep.
I was wondering, is there just a way to do it?
Oh, there's a very interesting way to do it in XPath. So the question is, how do you find unique items? So there's, well, I should say there's not a unique function within XPath. I'll put it like that. Within XSLT, which uses XSLT and XPath, there are ways of getting unique items. And in XPath and XSLT2, that's a pretty easy task. You can select sets of nodes, and then you can group by an XPath expression. In XSLT and XPath 1, that was one thing the language does very poorly, and there's a way to do it, but it's kind of confusing, and I don't want to explain it here. So if you're strictly using XPath and not XPath along with XSLT, then you're probably best to find the unique values, the list of unique values, programmatically within PHP. If you're using an XSLT2 and XPath2 processor, then there are good ways of doing that. So then number 5 is exactly identical. No, that's not it. It's, so when we just have a number by itself, that's the equivalent of position equals that number. And so here we're just selecting the title of the very first item. Okay. So in terms of HTML, XHTML, right, we have an expression of HTML head title, right, that's pulling out the title element. And then the second expression here, we use the // and that's descendant or self. So we get down to the body, and then we basically say the descendant or body, the descendant or self of body, and we're looking for all A elements with an href attribute. So that would pull out, give us a sequence of all the A's, all the anchors within the XHTML document. Okay, so what's the difference between the following? So here we have HTML body // A, predicate A, href. Number 2, we have /HTML /body // A / @href. Anybody want to take a guess at that? Go. Okay.
The second one is looking for the child of A, so using inside A and then href.
That's exactly right. So the second expression that we have here is actually looking for the href that's a child of A. So what we're selecting are all the href attributes, or I should say, all the attribute nodes from the href attribute. In the first expression, we're selecting all the nodes based upon the A element. So the difference in this, I just kind of wanted to highlight that the predicates really filter what we're selecting. They don't change what we're selecting. Good. Okay. So if you're using a compliant XPath processor, there are some XPath functions that you have available to you. XPath 1.0 has a pretty limited set of those, and they're listed here. We can do things like count and do ceilings and floors, and we saw the position, right? We have some very limited string capability of starts with, string length, substring after, substring before. With XPath 2, we have a lot more flexibility than this. There's more than 100 functions available to us, a lot of them dealing with regular expressions, a lot of them dealing with dates and times and intervals and things like that. So I think often you'll find that if you're within XSLT and XPath, then you can do a lot of things with that within, particularly with version 2.0. If you're dealing with XML primarily within PHP, for instance, the list of functions you have available to you within PHP far surpasses what you have here, certainly with 1.0. And so depending upon what you're wanting to do, your strategy might be to do some of the processing in PHP versus within XPath. Okay. So, going to bring in some help from some animals here to help us with XML. So we have the camels and llamas, and we have giraffes and okapis. And yes, what do these have to do with XML? Or what do these have to do with one another? And well, we all know that they're all part of the even-toed ungulate family, right? And so we're going to take a look at, if we think back to the last time we took some high school level or maybe college level biology, where we learned about taxonomy of the kingdom, phylum, class, order, family, genus, species. And we aren't going to look at the whole data set for the world, but we're going to look at my very simplified data set, which includes the order of the Arteriodactyla, or the even-toed ungulates. And even this order is not fully populated, but I put some of my favorites in there, which include camels and llamas and giraffes and okapis. So we have kind of this hierarchical structure of our taxonomy, the taxonomy root element. So then we have our kingdom, the animal kingdom. I'm just going to open this up and we'll see it. So we have our kingdoms, only the animal kingdom is populated, right? And then we have the chordates and the mammals within that, etc. So then, we have our camels here, and we have the Bactrian and dromedary species. We have a few species of llama, and then the giraffes and okapis, which are sort of genus cousins. So we're going to take a look at what we can do XPath-wise with these. And we don't have time to do it. We can do some neat things with an XSLT perspective on this, but we aren't going to do that right now. So for a given species, find the others in the same genus. Okay, so genus is one level above species. So our XPath expression, we could just do descendant or self to find the genus predicate whose species name is equal to, in this case, the llama guanaco. And then, so that's going to select the species that's or the genus that's a parent of the llama guanaco, and then we're going to select all the child species of that. So that's going to return a sequence of all the species that include the llama guanaco plus its siblings, species siblings. Another way we could do that is that we could do descendant or self, selecting all species whose parent colon genus species name is equal to the llama guanaco. So these two XPath expressions are really going to give us the same thing. They're just slightly different ways of looking at it. Furthermore, right, we could find the siblings, we could find all the preceding siblings, we could find the llama guanaco itself, and then find all the following sibling species. And those three things together would be the same sequence as what was selected before. Okay. Now, one thing that we're doing here is that these XPath expressions are kind of assume that our context is our document root, or at least very high up. So they can get more interesting if we assume our context is, that llama species. What would be the expression then for that? So that's an important thing to keep in mind, and I'm not sure, from what I saw of the XML simple, and I must say I'm not intimately familiar with it, but it looks like most of those XPath expressions assume the path relative to the entire structure. Is that right? Okay. Thanks. So that's kind of one thing to keep in mind. So the other thing, another type of problem to think about is, what if we wanted to grab a sequence of all the nodes that are, in a sense, pruned to a specific species? So, for instance, for the giraffe, we want to grab that specific species. I'm not going to be able to work backwards, but then we want to grab the genus, order, family, and on up the tree. So that if we were to look at that sequence, we'd see something like, animal kingdom, the chordates, mammals, et cetera, on down. So for that, we could grab out, and here we're using a wildcard pattern for really any element name. So we have our root element taxonomy, descendant or self, any element, and the predicate on that any element name is the descendant or self species, the name equals to be the giraffe camelopardalis. So that would give us a sequence then of the kingdom, phylum, class, order, family, genus, and species of this particular giraffe. Okay. So then you can imagine we might develop some, instead of using strings in here, we want to use variables, and we could have XPath expressions that would return things based upon whatever input that we have. So one thing that this doesn't show, and it's unfortunate, is that in the case of pulling out the kingdom, phylum, class, order, we're pulling out a sequence, so we've really lost all the hierarchy. Sometimes we might want that, but sometimes we don't want to lose that hierarchy. So to kind of retain any sort of hierarchical structure of the original XML, we'll really need to use some of our XPath expressions within the context of XSLT. And that I hope we get to see at least a little bit tonight. So we talked a little bit about defining XML documents. So things can be well-formed, and then we can actually define a particular grammar that says what elements are there, what elements can be contained within what elements, et cetera, et cetera. So ways we have of doing this are through DTDs, through W3C XML schema, through Relax RNG or RNG, and schematron. Now, if you want to know more about these, you can look up and see what they do. But just to kind of briefly talk about some of their features. DTDs have their history in the world of SGML. So a lot of mature XML applications are defined in terms of DTDs. So DocBook, XHTML are the two ones that come to mind. And there are certainly others as well. For anyone who's dealt with either writing the DTD or reading the DTD, you know that the format is not intuitive. Okay, it's not very fun at all to deal with. On top of that, you have some very limited abilities to define your grammar. You don't. It's not natively namespace aware. It doesn't deal with data types. It has very limited ability to express ordering and limits on how many things can occur. But if you deal with XML, you're going to run across DTDs just because there's so many of them out there. If you're starting something from scratch, you probably don't want to choose a DTD. You probably want to choose one of these other methods, and probably either schema or RNG. Both schema and RNG, their document formats of defining are XML based. That's one common thing that you'll see in the world of XML is that, source is XML, data formats in XML, XSLT is defined in XML, and that a lot of things use XML, and it makes things at least internally consistent. So both of them have data types, so we can say that an attribute value must be a date or must be an integer, etc. They're namespace aware. In terms of the W3C XML schema, it's really the W3C way to define XML applications. RNG kind of came around because people thought that W3C XML schema was kind of heavyweight. To do some simple things, it took like a lot of work to do. And that's an oversimplification of the argument, but that's the one I'll make tonight. And so really both W3C XML schema as well as RNG are very, very solid ways of defining your XML grammars. RNG also has what they call a compact syntax format, which is not XML based. A really interesting one is schematron. And it's interesting not that it's widely used, but it's for certain cases it's perfect. So it's all rules based. Rules, there's an XML format to express these rules, and these rules are all based on XPath. And so if you can write a rule or an assertion in XPath, then it can be a schematron rule. So you could do interesting things like, you could have a schematron rule that says, pages on the company website must refer to the site CSS document for consistency, or must have the copyright statement. You can write, those would be really impossible, I think, to express in terms of RNG and W3 schema. But you can express those rules in terms of schematron. And so schematron gives us kind of some flexibility to, in these cases where we need to write some custom assertions and rules, that we can actually formalize those and put those out. And if we know XPath, we can write schematron rules. So why bother? Why bother with definitions and validation? Well, if we have a definition for our grammar, we can confirm that the XML that we're producing conforms to that grammar. The programs that we have that parse that XML can also understand those definitions, and it can either validate it before or run some validation checks before it begins to process it. So it's not trying to process bad data. Okay, so anytime you accept input, you want to verify and validate it. This makes it easy. It also gives us a way to document it for people. So all of these grammars or ways of defining XML, we can produce kind of XHTML or web-based documentation that it's meant more for people to read. Okay? So if somebody wants to know how to write that XML that you created, then point them to the documentation. Some XML editors, the higher end ones, will use those schema rules to provide kind of a guided editing environment for the users. Okay? So if you're going to turn your pizza markup language over to the guy that's behind the counter that may or may not be an XML expert, it might be very helpful to have a guided editing environment. It might be helpful for you. And also it just fits with the maxim of be conservative with what we generate. Now with that, and as much as I like validation, I'm going to acknowledge the fact that sometimes you won't bother, and sometimes I don't bother. So if you're getting XML from others, you have one choice. You can try to process it. If you try to validate it and it fails, then you don't get anything. Sometimes that's what you want. Sometimes you want to take what you can get and take what you can use. If you have simple formats, it's probably not worth it. If you produce and consume your own XML, and you'll probably be doing a lot of that in the Ajax environment, hopefully you have a trusted source, and so the validation is less of a concern. And if you have really, really huge XML, then there are some validation costs in terms of time and processing. But in general, you can still define your language and then just choose not to validate it at runtime. But you can still have that as a way to formalize, and instead of having a text description of what has to be contained in what, you have that formalized, and people can then interact with that in a more stringent and better way. Back to the question earlier about designing markup. So, and this is an art as much as anything else. And I think three things to consider when you're talking about creating a markup language de novo. And that would be, really think about how's the XML being created. And that might inform, but it shouldn't be the end-all, be-all. How is the XML being used? And this is probably the more important thing, to be honest. And then lastly, think about what's this markup, or what's it really describing? What's sort of the underlying data? And we kind of want to think about all those as we kind of create the markup language. So some things we want to avoid. So if we have a database structure or a Java object or something, and we just want to serialize that out to an XML format, that's probably a bad choice for a variety of reasons. So obviously we want our XML markup to reflect some aspects of it, but we don't want to just dump it out unthinkingly. Think about it first and then put out what's necessary. We don't want to overstuff. Overstuff, we don't have to have an element, for every single atomic thing. Sometimes we might want to, but sometimes the tendency can be to create too much. And then lastly, using kind of a pointer-heavy document. And this might happen if we're trying to turn a relational model with several different tables into a flat model in XML. And we're probably better off using the hierarchy that XML allows to reflect any sort of hierarchical data or nested structures that we have. So I mentioned Norman Walsh earlier. Jenny Tennyson is another one that whenever she writes something about XSL, you want to pay attention to it. She has a great article about bad XML from May of 2008. And it's not long. I suggest you take a look at it. So it says really the main, it says you can basically tell when people, if people approach the problem from, I need to create a markup language perspective, you're going to have a much better chance of success than I have this data model that I need to serialize. Yeah. So she says kind of good XML relies upon custom names. So these are custom element names. And we'll see an example here that defies that. Mixed content. Okay, so mixed content, we can have text, we can have elements mixed together if we need to. Nesting, we've already talked about that. The use of attributes along with elements. Of using untyped data and where we need to combine XML grammars using namespaces. Okay. So if we were to take a stab at a narrative document, something like this that we might want to mark up, maybe we produce something like this. Yeah, that's good. So if we were to look at just the text of this, we haven't changed any of it, but we've marked it up so that we can tell what are countries, what are geographic territories, what are organizations, right? What are people? So what are dates? So that if we were to process this, programmatically, if we had a bunch of text like this that were marked up, you could easily pull out, what are all the articles or paragraphs that mentioned the country of Georgia. Okay. Now, if we were to do a free text search on Georgia, we might pull up things about the country as well as the state. And so this is an example where markup, where we're using attributes to denote the data in the midst of the markup might be helpful. But in the pizza world, you're probably more interested in data-centric documents. So here's an example where we have a quote from Yahoo that's woefully old in terms of date and price. But so 3 different ways of really representing the same data. And so one, we have strictly element-based way of doing it. Company date, close volume. The second way, we use solely attributes. We have quote, company date, close volume attributes. And then lastly, we have kind of this mixed model where we use both elements and attributes. Now, if we have very, very large XML documents, tens of thousands of elements, then the attribute way is faster by about 30%. But I imagine for your pizza world, that's probably not going to be a concern. Whether you use an element or whether you use an attribute, there's really no hard and fast answer. In general, people use attributes as metadata for the content. So let's take a look here. So for instance, if we had the quote and we have the close value of 12.86, so the metadata about that 12.86 is those are US dollars. That might be appropriate for an attribute, right? Because it's sort of metadata about that particular piece of content. Okay. Just as as an example. Some people argue that in the world of XML, attributes are superfluous. You don't need them because you have elements, and you technically can express all that in terms of elements. But sometimes it's handy to have those certain things as attributes. Now, one thing to keep in mind, right? Attributes have to be text, so you can't have elements within attributes. And if you're going to have very, very long text, you don't want those as an attribute because that can just get kind of messy. So elements are flexible. They can contain other elements. They can contain text. Attributes are not. Remember that elements are inherently ordered. And the text that the elements contain can be lengthy. Use attributes for metadata. Keep in mind that attributes are cheaper in terms of space, bytes, and in terms of processing time. But limitations of attributes are they can't contain markup, their length, and that they're essentially unordered. Here's an example of a screenshot of an XML dump from some SQL tool, which is dumping a row from dumping a table out. And it uses a very generic, as you might expect, right? There's a root element table, there are row, children, and then column within that. So this works great because it can dump out any table that you have in the database in this format. In terms of working with this from an XML sense, it's a nightmare. First of all, it uses all capital letters, which is not the convention. It's not illegal, but it's not the convention. But it's just very difficult to use, to always be looking at the name attribute. And the more natural way, if you were to rewrite this in terms of XML, most of these column names you'd probably want in terms of XML or in terms of element names. Okay, and of course there's no hierarchy here, and you'd want to group and nest things like that. So let's take a look at an example with weather, and we're going to start with what the National Weather Service provides, and then we're going to try to improve upon it. And sadly, it looks like, well, the notes will be there about XSLT. But I think this is more relevant to your pizza, so this should keep everyone's attention for the next 9 minutes. So one thing, some observations about this is it's a very data-centric format. Okay, it's very flat in nature. I think the only nesting is in this image element where we have URL, title, and link. And why it's there and nowhere else, it's kind of puzzling. So it's very flat structure. The other thing to note, too, if we look at like the temperature, lines 23 and 24, element name temp_F and temp_C. Okay. So now if you're processing this, and you might be storing this away because you want to collect your own data over time, or you might be displaying it on a web page, you can certainly use this. Okay. And it's certainly very usable, and it works. But if we were to suggest some things to the National Weather Service, we might suggest some of these things. One is standards. So there are the ISO date and time standards that are commonly used in XML that are natively parsed and processed by both expressed by schema, by RNG, and XPath 2.0. So we might change our observation time to keep that string in there because maybe we want to just have a way to easily display that to the user. So we can keep that in there, but as an attribute, maybe we add in a data format the actual time stamp in terms of the ISO world. Okay, so we could do something like that. It also might make sense, instead of having that as its own separate element, maybe consider the timestamp to be metadata for the whole document, which is a root element of current observation. I mean, that sort of makes sense. Current observation, well, what does that mean? Well, you have the time attached to it, right up there. And that describes the whole document. That is one massive mosquito that's flying up in the screen. Oh my gosh. And I bet those of you at home probably saw that. That's scary. Okay, another thing we might do in terms of standards is go back to what we learned with RSS and the geo lat long. And they have, for a location, right, they have the Boston International Airport, the station ID, and they have a latitude, longitude associated with that. And these are all flat. So you wouldn't necessarily know they're associated. So we might do something like this. We might want to move the latitude and longitude as use the geo namespace, and so we'd have to define that in our document. But put those as attributes, or we could put those as elements, but put those so that we know they're related to the location. Okay. And typically IDs and things like that, I personally consider those metadata and usually put those not as elements but as attributes, because they also tend to be very easy to select against. So if you're selecting all the courses of a particular department code as an example, that XPath expression is very easy if we use attributes. So we might move them up into attributes. We might keep them as elements, but we want to attach them to the location. So we might put them as children of location or attributes, and we want to use the standard way of referring to latitude and longitude. There are other ways we might nest things. So here we have wind measurements, wind string, wind dir, wind degrees, wind MPH, and wind gust MPH. So these are all flat. So I guess if we were selecting all those, we could select all the elements that begin with wind and know that those are all together, but that's usually not intuitive. So why not group all the wind together, and then we can have direction, speed, gust within there. So the other thing, too, is we move the units, instead of having those be sort of embedded as underscore something within an element name, just put those as attributes. So the speed is 3.45. The units for that are miles per hour. Shouldn't that be gust on line 4? Yes, you're right. Yes. Line 4, close, tag, gust. You all are paying attention. I like this. Thank you for that. I'll get that corrected. So this is an example of not well-formed XML. And so that way, if we wanted knots, we could still have speed and gust. We would just have different units. Okay. And again, so the other thing that we still keep is display. And sometimes that's a useful thing, to still have string-based elements within XML that are just useful for displaying, even though we could recreate that string based upon all that other information. Sometimes it's just nice to have there when we're processing. Yes?
So I know you covered this tonight, but just to be clear, let's say you wanted to also list, like you just said, wind speed in knots. In that same window, is that legal or not?
So the question is, if we wanted to display the wind speed in knots within that same element, in addition to, would that be legal? Well, I guess two things. One, it would be depend on how I define the markup language. I could constrain it so that it's not legal. But in general, from an XML sense, it might be perfectly fine. But we're going to take a look at how we might do that differently. So here we have an example. So we have temperature and pressure. We have different units. Fahrenheit, centigrade for temperature, millibars, and inches for pressure. And these are English units and metric units, right? So, they have temp underscore F, temp underscore C. So one thing that we could do is take those temperature elements and put a system attribute. So we could have an English system, we might have a metric system, internet SI system, if we wanted to express temperature in Kelvin. So something like this would be very, very flexible. If we needed a new system, we have the temperature element. It just needs it doesn't even need a new attribute. It just needs a new attribute value. With the original way of doing it, we needed to create a whole new element, multiple elements every time we introduce or we want to have a new system. So then the other thing that we could do under improved 2, maybe it makes sense to have temperature, and then within there have several different readings, and these readings might have values, might have systems attached to them, and might have units and labels associated with them. So that if you can think as we process, if somebody wanted to see all the metric, well, that would be easy to pull out. And then it would be very easy, regardless of the reading, it would be very easy for us to display it. We have a value, and we have a label, and we have the units. Okay, so regardless of whether it's temperature or pressure or wind speed, we can use the same logic to display that item. Okay, Likewise, we could do the same for pressure as well. Okay. Now, this also, we talked about, to ask yourself, how is this going to be produced, and then how is it going to be used? So if we're getting these temperature readings from somebody, from a system, the different units are just a mathematical conversion. So it probably makes a lot of sense to output all the different types of units we want together. So under improved (3), we kind of turn it around and say, well, we want our basic definition to be English units, and within English units we have all the different measurements. Within metric units we have all the different measurements. And this is one way of doing it. Maybe this is it might be slightly easier using it, but it's probably going to be a lot harder to produce it. And again, it's a judgment call as to what you end up doing. My gut is that option 2 is far better than this one in terms of XML and in terms of data structure. But think about that when you approach your pizza. Think about the poor person that has to author the document. Think about poor you who has to process the document. Right? Think about flexibility. What happens if we have a new measurement later on? What happens if there's a new pizza topping or a new size? They want to offer extra large or personal, okay, or by the slice. Okay, how does that alter things? Is your markup flexible enough that you can deal with that? And is your processing flexible enough that you can deal with that? Or does everything fall apart? So I hope you have fun with that challenge, and thank you again for your attention tonight. It was a pleasure to be here.